Okay, so we are recording this, so you could have it available to you later. Today we're going to cover the rest of the rules of exponents. Last week we covered the rules 1, 2, and 3. Today we're covering rules 4, 5, 6, and 7. And later on I'll be giving you this piece of paper right here that has all the rules explained in words and in example, and even with more examples. Anyway, let's move on to rule 4. Or how about this? Let's review rules 1, 2, and 3. Rule 1 was that if you're multiplying two terms with the same base, you add those exponents. So 2 plus 3 is 5. Okay. We also explained last week that these rules weren't created by someone. It's just an observation of the truth, and it's like a shortcut, right? You could expand them and understand that when you have a power to a power, you end up multiplying. 2 times 3 is 6. And rule 3 was where we had parentheses with an exponent on the outside, and you would have to distribute that outside exponent to each inside exponent. So you distribute it to the 2, which has an exponent of 1, distribute it to the power of 2 on the x, to the power of 1 on the y, to the power of 5 on the z. And of course, remember what we just said about rule 2, that a power to a power you multiply. So right here, we are doing exactly that. 3 times 1 is 3, so you'd have 2 to the third. And if you think about what 2 to the third is, that's really 8. And then 3 times 2 is 6. That's how we get x to the 6th. 3 times 1 is 3. And 3 times 5 is 15. That's how we get 15 over here. Okay, so that was rule 3. And if you understand rule 3, which we already had a quiz on last week, you should easily understand rule 4. Because technically rule 3 and 4 are the same thing. You see rule 4 down here, you have parentheses with an exponent on the outside, exactly the same as rule 3, and you distribute it to each and every exponent, right? This outside exponent gets distributed to the power of 1 on the 3, to the power of 4 on the x, and to the power of 3 on the y. So when you distribute 2 times 1, that'll be 2, so you have 3 squared, which will become 9, and then 2 times 4 becomes 8, and 2 times 3 becomes 6. Now, the number one mistake that I see students make when they distribute the exponent, whether it's rule 3 or rule 4, students, when they distribute the 3 to the 2, for some reason they think that it's the number 3 times the number 2, and they write down 6, and that's wrong, okay? This is not the number 3. This is the power of 3. So you're going to end up with 2 to the power of 3. Right here, same thing. It's not 2 times 3. It's 2 multiplied by that power of 1, which is 3 to the second power, and 3 to the second power is 3 times itself, 2 times, which is 9. 3 times 3 is 9. So I hope we get rule 4. Once again, for the notes today, just write down exponents, rules 4 through 7. And let's actually stick with rule 4 for a little bit longer. So if you're on your notebook, which you should be, and you want to jot down some notes, what I would say is, let me highlight what I would write down. I would just write down the words distribute exponent, distribute outside exponent to each inside, and I would also put exponent. Okay, so if you're just jotting down some quick notes, rule 4 is the same thing as rule 3. I would write down distribute the outside exponent to each inside exponent. Okay. So just write down distribute the outside exponent to each inside exponent. And you should already know that a power to a power you multiply. So right here where I highlighted, distribute outside exponent to each inside, but also add the word exponent. Okay, so if we take a look at, don't copy this down. These were examples from rule 3. We already know that you simply distribute the 3 to each and every term. So just quickly, could anybody tell me what the answer to number 1 is? Don't even write it down. We already did this last week, but could anybody tell me what the answer to number 1 is? Yeah, go ahead. Okay, so I appreciate that. When you distribute, keep in mind that it's not the number 3 times the number 2, right? Like if I actually wanted you to multiply 3 times 2, I would have put a 3 out here in the front because that's a regular number 3. 3 times 2 is 6. But this is not 3 times 2. This is the power of 3 that's being distributed, right? So it's not 6, but it's actually 8. There you go. Okay. Because again, that 3 gets distributed and you're going to end up with 2 to the third That's an ugly 3, I apologize. And then, yeah, x to the 6th. So final answer, 8x to the 6th, right? How about this last one? Super easy. What's the answer to that one? Anybody? 8 x to the... Okay, remember, power to a power, you multiply. So there's a 1 right there, a 1 right there, a 1 right there, a 1 right there. So you're distributing it to each and every power, and you're multiplying them. That's how you get 2 to the 3rd, which becomes 8. X to the 1 times 3, that's x to the 3rd, y to the 3rd, z to the 3rd. Cool? All right. So I hope we get that. That was from last week. That was rule 3. The only difference now is that we're throwing in fractions inside the parenthesis. And of course, if there's no addition or subtraction, you are allowed to use this rule of distributing the outside exponent to each inside exponent. So everybody please copy down this example number 3 right here. Let me make some space by moving this stuff out of the way. Example 3. So you're going to write down some big giant parentheses. You're going to put the power of 3, and on the inside you have the fraction x squared z to the 4th over 2y to the 5th. And again, whenever you see parentheses with an exponent on the outside, that should remind you of what you need to do. That you need to distribute that outside exponent to each inside exponent. And of course, you're going to be multiplying those exponents. So if I take this power of 3 and I distribute it to the power of 2, I'm going to multiply it. 2 times 3 will be 6. So when I write my answer over here, it's going to be x to the 6th. And then 3 times 4, because power to a power you multiply, you're going to have z to the 12th. And then distribute 3 times, there's an invisible 1. It's not 3 times 2. Don't write 6 down there. There's an invisible 1 right here. So 3 times 1 is 3. And if you think about what 2 to the 3rd actually is, it's actually 2 times 2 times 2, which is 8 on the bottom. And then you distribute the 3 to the power of 5, power to a power multiply, you're going to end up with y to the 15th power. And there's your final answer, x to the 6th, z to the 12th over 8, y to the 15th. You get it? Fun stuff, huh? Okay, let's try one more. I apologize for the disgusting handwriting here. It says, giant parentheses, 2x squared y, student last period thought that was a 4, that's a y, over 3z to the 3rd, all to the power of 2. So I want to pause it right now. Go ahead and work it out. Let's see if we could get a right answer. So the reality is, guys, many of us will be able to do this in our head, right? Maybe not right now, but once you practice it enough, you'll be like, oh, I know that rule. I need to distribute this outside 2 to each inside exponent. So 2 times, it's not 2 times 2. It's the invisible power of 1 right there. So you're going to end up with 2 to the 2nd. And then you take that 2, distribute it to that 2, power to a power multiply, you're going to end up with x to the 4th because 2 times 2, whoops, sorry about that. 2 times 2 is 4. And then distribute 2 to that power of 1, that'll be a y to the 2nd. Over, distribute 2 to the power of 1 on the 3, that'll be a 3 squared. And then 2, distribute it to the power of 3 right there. That's going to be a z to the 6th. So what else could we do? We could simplify the 2 squared, that'll be 4. Just simplify the 3 squared, that'll be a 9. Final answer will be 4x to the 4th, y to the 2nd, over z to the 6th. 9z to the 6th. Get it? All right, so rule 4, it's pretty much the same exact thing as rule 3. You're just distributing it to more terms because you have a fraction. Distribute it to everything up on top, everything on the bottom, every exponent up on top, and every exponent on the bottom. And remember that you multiply those powers. Let's move on to rule 5. You're going to love this one. This is my favorite one, hands down. This is like finding money on the ground. When you have these types of questions on the quiz, it's awesome, okay? Go ahead and write this down. Rule 5, anything to the power of 0 or anything to the 0 power equals 1. You get it? And then write down this example. X to the power of 0 equals 1. And then go ahead and write this example. 5 to the power of 0 equals 1. That's right. What if I said, how about y to the power of 0? What does that equal? What? 1. What if I said 3,524 to the power of 0 equals 1? Pretty easy, right? Anything to the power of 0 equals 1. Cool. What if I asked you, how about 2x to the power of 0? What does that equal? It's not 1, it's 2. It's 2. What? Why is the answer 2? You guys, I just said anything to the power, that's what it says up here, anything to the power of 0 equals 1. Why is this not 1? Because what has a power of 0? The x. Does the 2 have the power of 0? No. So this is still true. This is the only thing that has a power of 0, so this becomes 1. So in reality, this becomes a 1, and of course you have 2 times 1, that equals 2, the answer above, right? So that's the only curveball that could happen on this rule right here, okay? So make sure you understand that. Let me move this out of the way. Let's get some more examples here. Look at number 4. I'm going to go backwards here. That whole thing, you don't have to copy this down, right? It's too much to copy down. But what you got to understand here is the whole thing. I mean, yes, you could distribute 7 on the 3, 7 on the 4, 7 on the 5, 7 on the 4, 7 on the 13. That'd be a waste of time because at the end of it all, you're going to have to distribute this power of 0, the whole thing to the power of 0, that equals 1. Makes sense, right? Okay. Same thing with this guy right here. If you have the whole thing in parentheses to the power of 0, it's going to equal 1. So you don't really have to copy these down. I just want to show you these different examples. But you got to be careful when it comes to this one, 1 and 2, where I say 2x to the power of 0, that's actually equal to 2. We should have written it down already. But if the whole thing's in parentheses to the power of 0, that equals 1. Okay. How about, what if, get this out of the way. What about this guy? Everybody copy this one down. 3x to the 0, y to the 5th, z to the 0. What's that going to equal? 3y to the 5th, right? It becomes as easy as this. Anything to the power of 0 equals 1. So this is 1, that's 1. So what it really says is 3 times 1 times y to the 5th times 1. And actually showing this work is a waste of time because you know that multiplying by 1 doesn't change anything. So technically, from the beginning, you could just say, well, that disappears and that disappears. My answer is 3y to the 5th, right? So that's rule 5. And I know you love it because I do. Super easy. Anything to the power of 0 equals 1. Anything to the power of 0 equals 1. 8 to the power of 0 equals 1. Juan to the power of 0 equals 1. Anything to the power of 0 equals 1. Okay? Moving on. Next rule. Rule 6. Okay, so rule 6. What are we going to write down? Let's first read it, understand it, and then you could write it down. Anything with a negative exponent must be moved from one side to the other, from the numerator to the denominator, or vice versa, and the exponent will become positive. Okay, so even though there's no actual name for this, I call this the negative exponent rule. Anything with a negative exponent must be moved to the other side of the fraction, from the numerator to the denominator, or from the denominator to the numerator, and it becomes positive. And the exponent becomes positive. Okay? So this rule is also pretty simple. All you're doing is moving things from one side to the other. So if you look at this example right here, what's the only, out of these, okay, we are ignoring this. Let's pretend we don't know the answer yet. Out of these terms, which one has a negative exponent? What variable has a negative exponent? The x. That's the only thing that has a negative exponent. So the rule says that if you have a negative exponent, you need to grab it and move it to the other side. So I'm going to take this. I like circling what I'm going to move, and I like drawing arrows. Take it to the other side. So since the y didn't have a negative exponent, that's going to stay up on top. Y to the 5th is still up there. This x to the negative 3 moved down to the bottom, and it became positive. And of course, the z is still there. So there's your answer. Now, it could be where you have negatives in the denominator, negative exponents in the denominator, that you move them up and they become positive, or negative exponents in the numerator, you move them down and it becomes negative. Okay? And technically, this even works backwards, where like if you really wanted to, you could move a variable up and it just changes the sign. Okay, this is kind of weird, but like let's say you had x to the third over x squared. If you wanted to, you could move this up and it'll become x to the negative 2. So it doesn't have to be where negative exponents are the only thing that you move. You could even move positive. You could use it backwards to move a positive exponent up to the top and it changes the negative. And then you could use rule 1 right here of adding those exponents and the answer would be x. Okay, maybe that's too confusing. Forget about that for now. Let's just stick with the basic rule that if you have a negative exponent, move it down to the other side, it becomes positive. Copy this one down. Everybody jot down 2x to the negative 3 equals, what do you guys think this equals? What's the answer? Okay, let me ask you this. What has a negative exponent? Does a 2 have a negative exponent? No, only x. So this guy right here is the only thing that has a negative exponent. That's the only thing I need to move to the other side of the fraction. And if you're thinking, what fraction? Everything's a fraction. Just put a fraction bar right below it and move this down to the bottom. And you're going to have the fraction bar, what's left over up on top. The 2 didn't move, it stays up there. And the x to the negative 3, it moves down and it becomes positive. And that is your answer, 2 over x to the 3. I hope you get that. I hope you have it in your notes. If we take a look at number 2 over here, compare number 1 to number 2. Number 2, we have the whole thing, the whole entire thing in parentheses with the negative exponent on the outside. So there's a couple of ways of doing this. One way is to distribute the power to both terms. That's rule 3. And then move the negative exponents to the other side and they become positive. Or since the whole thing is in parentheses, you could move the entire thing, this whole thing, move it to the other side, and you will have nothing left up on top. And when you have nothing left up on top, you have a 1 up there, and you would now have a positive power of 3 with the 2x inside. And then you would have to distribute rule 2, right? So as we move on, we're going to get different questions that have more than one rule to apply. And this is one of them. We have more than one rule to apply. We have the negative exponent rule, moved it down, but we still have that distribution rule. We have parentheses with the exponent on the outside, you distribute it to both terms. So what we have here is 1 up on top over 2 to the third, x to the third. So your final answer is going to be 1 over 8, x to the third. Let's try another. Give me 1 second, move this out of the way. What the heck happened there? Man. There we go. Copy that one down. Number 3. Again, the only thing that has a negative exponent is the y to the y value. So I'm going to take that y to the negative 2, I want to circle it, I want to draw an arrow. Nothing else moves. So the 2 didn't have a negative exponent, the x didn't have a negative exponent. The only thing that had a negative exponent was the y, so the y comes up and it becomes positive. And there's your answer, 2y to the second over x. And that is rule 6. Anytime you have a negative exponent, move them from one side to the other. Of course, it could get a lot more complicated. You could have something like x to the second or x to the negative 2 over y to the negative 2, and that would flip it. It'd be y to the 2 over x to the 2, right? Because negative exponents move to the other side. You don't have to copy that one down, but just keep in mind, anything with the negative exponent must be moved to the other side, and it becomes positive. Let's move on to rule number 7, the final rule. I apologize. It seems like it's a lot, because it is a lot, but we're not going to learn anything else all week. We're just going to practice these 7 rules. Rule 7. I like to call this the canceling rule. I mean, You see, the number's not what's important. It's what you're actually doing in each one. Like if you think of rule 3 or 4, you could think of rule 3 or 4 as the distribution rule because you have to distribute the outside exponent to the inside. I like to call the rule 6 the negative exponent rule because anything with a negative exponent, you move it from one side to the other. Right here, I don't call this rule 7. I call this the canceling out rule. You got to cancel out terms from the numerator and the denominator. So when you have the same base, both on the numerator and the denominator, you get to cancel it out. And we have an example of this right here. But even before that example, before understanding that example, if I said, what's 5 divided by 5? What's the answer? 1. Why? Because the 5 cancels with the 5, right? Same thing with 3 divided by 3. That cancels, it's 1, right? Anytime you have the same identical thing on top and on the bottom, it cancels out. So what is happening with this first example that we have here right below the rule, we have x to the third, which really means, x to the third really means x times x times x, over x to the fifth, which really means x times x times x times x times x. And of course, we're going to cancel this x with that x, this x with that x, this x with that x, which means that the final answer is, since there's nothing left up on top, you put a 1, and you do have 2 x's left over on the bottom. So that's why this answer is 1 over x squared. So I hope everybody wrote down the rule. Rule 7, cancel out terms, cancel out like terms from numerator and denominator. This is also sometimes referred to as the subtraction of exponent rules. Because in reality, your mind, what you're doing is you're subtracting, right? It's a waste of time to actually show this. The bottom line is you got 5 x's on the bottom, 3 on the top, 3 cancel with 3, there's going to be 2 left over on the bottom. So I never actually show this work. If anything, I do this. I say all 3 exponents, or all 3 x's on top cancel out. So I put a line even through the x itself and the 3. All 3 x's cancel out with 3 of these 5, leaving me 2. So there's my answer, 1 over x squared. I hope we get it. Let's try this one right here. Go ahead and jot that down. So there's something different about this one. We actually have a 2 on top and an 8 on the bottom, okay? So whenever you have numbers like this, in reality, it's kind of like if you had a fraction. The fraction 2/8, what does that reduce down to? 1/4, okay? 1/4. So far, the 2 and the 8 reduces down to 1/4. And you could show your work by simply crossing out the 2, that's a 1, crossing out the 8, that's a 4. Why is that? Because 2 divided by 2 is 1, 8 divided by 2 is 4. Remember how to reduce a fraction? You just divide by a certain value, both on top and bottom, okay? Or if you wanted to think about canceling, another option would be to think of the original 2 over 8 and rewrite this 8, rewrite it as 4 times 2. So I could rewrite that 8 as 4 times 2. And then you could be like, oh, I have a 2 up on top and a 2 on the bottom. That'll cancel out. So what's my answer? A 1 over a 4. Okay? So it's up to you if you want to think of reducing the way you have since the 4th, 5th grade, or if you want to rewrite the 8 as 4 times 2, so you could visually cancel the 2 and the 2. Anyway, you're going to end up with the 1 over 4. And then you ask yourself, how many x's are on top? Oh, there's 3. 3, that's like an x times x times x. How many x's are on the bottom? There's 2, x times x. So we're going to cancel all 2 of these x's with 2 of these 3, leaving you only 1 left over. So on top, you have an x to the 1, okay? And then you have, let's deal with the y's. You have 2 y's up on top. That's a y squared. That's really a y times y. Both of those y's completely cancel out with 2 of the 5, leaving you 3 left over on the bottom. So you're going to have a y to the third. So the cleanest way of representing this final answer is just x over 4y to the third. You don't really need a 1 in front. You could put it if you want. And you don't really need the power of 1 up here. You could put it if you want. But that's the nicest looking answer for this example. Let's try another. All right, so I want to pause it. Somebody let me know once you get an answer. So yes, we have a correct answer. y over 3x. And let's go through this. If you wanted to, you could think of it as 4/12. 4/12 you could reduce by what? You could reduce by 4. So think about that. 4 divided by 4 is 1. 12 divided by 4 is 3. So 4/12 reduces down to 1/3. So on our answer, we have a 1 up on top and a 3 on the bottom. Okay, and then we move on to x's. Well, we have 1x up here, which will completely cancel out with one of the two down here, leaving you only 1 left on the bottom. Notice that I put a line through the whole x right here. I only put a line through the 2 and changed it to a 1. I did not go all the way through the x because I have 1x left on the bottom. And then again, we have y's and y's. This y will cancel out with one of these. So this y cancels out with one of these, leaving you only one y left up on top. So we do have 1y to the 1 over 3x to the 1. But of course, the best way to write that answer is just instead of 1y to the 1, we could just write y. And instead of 3x to the 1, just 3x. So y over 3x is the final answer there. Technically, we're done, right? Check it out. We have this worksheet that we're going to work on today. And on the back side of the worksheet, we have this entire detailed page of notes describing everything you need to know about rules 1 through 7 on exponents, right? So just a review. Rule 1, when you're multiplying two terms with the same base, what do you do with these guys? You add them. 2 plus 3 is 5, keep the base. Rule 2, when you have a power to a power, you multiply them. 2 times 3 is 6. Rules 3 and 4, it's technically the same rule. Anytime you have parentheses with an exponent on the outside, you distribute it to each and every inside exponent. Parentheses, exponent on the outside, distribute it to each and every exponent, right? Rule 5, my favorite one, anything to the power of 0 equals 1. Anything, so like happy face to the power of 0, that equals 1. Anything to the power of 0 equals 1, right? The only curveball is 2x to the power of 0, that equals 2. Because the only thing that has a power of 0 is this guy, not the 2, right? So it's really a 2 times 1 right there, which is how we get 2. Rule 6, anything with a negative exponent must be grabbed and moved to the other side, and it becomes positive, okay? So it's no longer up on top, it's now on the bottom. So the answer is y to the 5th over x to the 3rd z, x to the 3rd z. Rule 7, anything that has the same base on numerator and denominator will cancel out. Only when you're multiplying, that is. So you have 3 x's up here, 5 x's down there. 3 of them cancel with 3 of the 5, leaving you 2 left over on the bottom. And that's it. So knowing those rules, and by the way, they have the written description on each one of those, but knowing those rules, oh yeah, and we have tons more examples on each one of those right here, more examples. But knowing those rules, you should be able to do this entire worksheet, and the homework for today is to do the odd ones. And the beauty of math is when you learn all these different rules, it's like learning rule 1, it's like learning how to punch, right? And then learning rule 2 and 3 is learning how to like do a kick and like something else, right? And then you put all the rules together, then you know how to fight. So you put all the rules together here, you're going to be able to simplify any equation or any expression. I'm sorry, these are not equations. So let's take a look at example number 19, right? That one has actually 1 rule, 2 rules, 3 rules involved, right? Which rule do you notice that we could apply on number 19? Any rule, go ahead. The power 0, what happens with the power 0? It equals 1, so I could just say and scratch that out. Because if I were to change it to a 1 and say 1 times k to the 4th, it's not going to change anything. So you don't even have to write the 1 times anymore. You can just scratch it out and it's done. Okay, what other rule? That was 1 rule. What other rule? K to the negative 6. Anything with the negative exponent must be grabbed and moved to the other side of the fraction. Thinking, what fraction? Hey, just put a bar right here and now it's a fraction. And you move it to the other side and you're going to have what left over up on top? The k to the 4th did not move. Here's your fraction and you're going to have a k to the positive 6 on the bottom now, yeah? So that was a second rule that we applied. I mean, not rule number 2, but another rule that we applied. And is there any other rule that we could apply here? Which one? The canceling out rule, right? You have k's up on top, k's on the bottom. You have 4 k's up on top. That could cancel with 4 of the 6 on the bottom, leaving you 2 left over on the bottom. So your answer is, since there's nothing left up on top, you're going to put a 1 up there. And since there's only k squared on the bottom, you put the k squared on the bottom. And that's your final answer. Pretty cool, huh? We applied 3 different rules on number 19. And you didn't have to use those rules, particularly in that process or in that order. You could have said from the beginning, rule 1. You guys remember rule 1? When you're multiplying terms with the same base, k, you could add the exponents. So from the beginning, if you wanted to, you could have said, oh, I'm going to add 0 plus 4 plus negative 6. And it'll give me k to the negative 2. And then you would apply the negative exponent rule that you move it to the other side, and it'll become this answer that we got anyway. So there's many roads to the same place in math, okay? I don't know. Should we try another, or are we good? Okay, I'll take that silence as that you're good. 24. All right, let's look at 24. Nice. 24. Everybody, look at this fraction right here with the numbers. If you had 15 over 5, what would you say? 15 over 5. What? 3. Yeah, right? 3 over 1, right? So, yeah, 15 divided by 5 is 3. If you want to just think of it as reducing, okay, 15 or 5 divided by 5 is 1. 15 divided by 5 is 3. So there you go. You end up with the 3 up on top. Now let's deal with the variables. I have x's and x's. This 1x will cancel with one of these x's, the canceling rule, right? So this x completely cancels with one of these, and you'll have 5 left up on top. And then we have the negative exponent rule. Again, this single problem has 3 rules involved. The negative exponent rule is when you have a negative exponent, you grab it, you move it to the other side. Negative exponent, grab it to the other side. Oh, dang. And then we have even more rules, even more fun, right? So it's already looking like a mess. Let me rewrite what I have so far. I have a 3 up on top, 1 on the bottom. I have x to the 5th up on top, right? X to the 5th. And this y to the negative 9 is going to go down, and it'll become y to the positive 9. And the y to the negative 11 is going to go up, and it's going to become y to the positive 11. And then we notice, hey, we have the canceling rule again, right? We have 9 y's on the bottom, 11 y's on top. All 9 y's cancel with 9 of these, and you will have 2 left over up on top. So your final, super simplified, beautiful answer will be 3x to the 5th, y to the 2nd. You could put it over 1, but we know that dividing by 1 doesn't change anything. So that's your final answer right there for number 24. Isn't it beautiful? Yes, it is. I know what you're thinking. You can't believe that all this entertainment is free, okay? Guys, please don't try to pay me money. There's no admission fee or anything. This is all free, right? I get paid enough. Okay, cool. You guys crack me up sometimes. Actually, I crack myself up sometimes. Anyways, I'm done. The video's been long enough. Let's work on this. Do at least the odd ones. 1 through 25, odd. Go for it.